Hey everyone, my name is Joseph Jimenez. I'm going to be working on problem 64 of chapter 9. It's a pretty long problem, so bear with me. The question is, a 10-gram bullet is fired into a 10-kilogram wood block that is at rest on a wood table. The block with the bullet embedded slides 5 centimeters across the table. What was the speed of the bullet? So first off, it doesn't say it's frictionless, so we know we're going to have the coefficient of kinetic friction involved. And in the book, it says that that is going to be 0.2. So it gives us the mass of the bullet, 0.01 kilograms, mass of the block, the initial velocity of the block, which was at rest, so it's 0 meters per second. And then we have the original distance, the final distance, how much it moved. And some of the equations we're going to be using to solve this problem is remembering that impulse is equal to the change in momentum, which is the average force times the delta time. And in this case, the force average is going to be the kinetic force times the delta time, which is going to be equal to momentum. And something to keep in mind is that the normal force is equal to mass times gravity. And so when we're solving for our kinetic force, we're going to insert our kinetic coefficient times our normal force, which gives us 0.2 times 10 kilograms for the block, and then 0.1 kilograms for the bullet, times 9.8, which gives us a force of 19.62 newtons. So now we go back to our F equals ma equation. And so we have F, which is negative 19.62 equals mass times acceleration. And we're going to divide all this by mass to get acceleration alone, which is negative 19.62 divided by 10.01 equals acceleration, which equals negative 1.96 meters per second. Sorry, it's right there. So from there, we're going to calculate our initial, and this is for the system, and we want to eventually get it just for the bullet. So from there, we're going to use the old kinetic equation of v velocity final squared is equal to velocity initial squared plus 2 acceleration of x times the change in x. So I'm going to go ahead and put that on the board, and then we're going to start over. And like I said, it's kind of a long problem, but bear with me. It's actually really cool once we can separate the bullet from the system. All right, everyone. So we're going back to kinematics, right, when we first started the semester. So we have the velocity final is equal to velocity final squared is equal to velocity initial squared plus 2 times acceleration times the change of position. And so we know that the final velocity was equal to 0. So from there, we're going to subtract the velocity, the initial velocity, because that's what we're trying to solve for. So we're going to subtract that on this side, and then we're going to multiply everything that we were given. From there, we get a negative velocity initial squared is equal to negative 0.196, and the negatives are going to cancel. So we have v initial squared is equal to 0.196, and then we're going to take the square root. So we get velocity initial is equal to the square root of 0.196, which is equal to 0.443 meters per second. And that gives us the initial velocity of the system. We're going to use this velocity to now find the momentum, because we know that the momentum of the final is equal to the momentum of the initial. So we're going to use that equation to be able to solve the rest of the problem. So I'm going to pause it and write that up on the board. Alright guys, so this is where it gets a little tricky. So we're going to use the equation because we know the momentum for the initial is the same as the final. So we're going to use the mass of the bullet times the initial velocity of the bullet plus the mass of the block plus the initial velocity of the block is equal to the mass of the bullet times the final velocity of the bullet plus the mass of the block times the final velocity of the bullet. So I know that's a lot. I started to shorten it by just using the BU for bullet and then B for block. We know that the initial velocity of the block right here is 0, so we're just going to cancel that out. So right here we get the mass of the bullet of the initial times the initial velocity of the bullet is equal to the mass of the bullet times the final velocity of the bullet plus the mass of the block times the final velocity of the block. Well, from there we get the final velocity of the block is equal to the final velocity of the bullet, which is equal to the final velocity, because once the bullet hits the block, they're moving together. So from there, we're going to do the mass of the bullet times the initial velocity of the bullet is equal to the mass of the bullet plus the mass of the block times final velocity, because we're just pulling this out, because if we multiplied it, then we get back to this. So from there, we get we're going to rearrange it so it's the initial velocity of the bullet is equal to the mass of the bullet times plus the mass of the block times final velocity over the mass of the bullet that we divided out from here. So we get 10.01 times 0.443 over 0.01. Sorry. We get all that is equal to the initial velocity of the bullet, which is equal to 443 meters per second. So it was a lot. We had to do this in parts, but really it's just knowing the equations. And what helps is recognizing that we were going to use the bullet and the block as one single entity, because if we hadn't realized that, that would have made the problem just so much harder and we wouldn't have gotten through it. So anyway, that was problem 64. Thanks for bearing with me. I'm gonna work on a few more problems and make another video. Thank you.